Okay, so section 2.2 is more on functions and their graphs. So we're going to talk a lot about increasing, decreasing, and then piecewise functions, just evaluating them. So remember, a function is increasing if it's rising from left to right. It's decreasing if it's falling from left to right. And it's constant if there's no change as you move from left to right. A function can increase or decrease or both. But it can't do both at the same time. So it can increase over a certain interval and it can decrease over a certain interval. But you can't increase and decrease at the same time, but one function can do both. All right, so some examples. Both of these functions increase and decrease over different intervals. So what we're supposed to do is state the intervals where it's increasing, decreasing, or constant. And what messes people up is when they're doing it, they try to give me y values. And when you give intervals, you have to give x values. So if you look at these functions, this first one, it is on this little chunk of the graph. If it'll let me do it, is decreasing. I had to go down to draw that picture. So I'm going to say that my function is decreasing. If I write in yellow, you're not going to be able to see it. Maybe you can. All right, so we are decreasing on the interval from negative infinity to 0. All right, so then the next little chunk of the graph from here to here, we went up, so that is increasing. I didn't change my color. And it's increasing from 0 to 2. So the mistake that people will make is they tell me it increases from 0 to 4, but we have to give x values when we're talking intervals. So it's from 0 to 2, the y values are increasing. All right, so then we have another little leg that is decreasing. So this part is decreasing. So we are going to add another interval where we are decreasing. Again, I didn't change my color. We are decreasing from 2 to infinity. All right, so this next little comment down here says the points where a function changes from increasing to decreasing and vice versa are relative max and relative min. So if I go from decreasing to increasing, I have a valley. So that would be considered a relative minimum of 0. Goodness, let's just completely start that over because that's a hot mess. Try that again. Relative minimum is 0. Now, the reason it's considered a relative minimum is because the function goes beyond that, but that is the lowest point in that area. All right, if we come up here, we're increasing and then we're decreasing. Well, the point at the top of that hill is considered a relative maximum. And when you talk relative max and min, you're giving a specific value. So that is the y value. So it'll be 4. All right, I'm going to erase all of that so we can talk about the next picture. All right, so for the next picture, we are on this first little chunk of the graph. We are increasing. I'm struggling hard to follow the picture, sorry. We also, at this point, pick up and increase again. So I'm going to give you both of the intervals where it's increasing. It is increasing from negative infinity to negative 1. And then again from, we'll call it 1 to infinity. All right, so then in between those, it will be decreasing. So we'll say that it decreases over the interval from negative 1 to 1. You notice how these numbers match? That's always going to happen. Anyway, so then we have a relative maximum here. Jeez Louise. Okay, sort of. You can kind of see that. So we have a relative max at, if that's 5, we can say that maybe that's 2. And then we have a relative minimum at about -2. All right, so here's one for you to try. When is it increasing? When is it decreasing? When is it going to have a max or a min? When is it constant? All right, so let's start with increasing. So remember, we go from left to right. So this is decreasing, constant, increasing. So it increases from 0 to infinity. Open and closed circles don't really matter when you're talking intervals for increasing and decreasing because you always use parentheses. All right, we are decreasing from -infinity to -4. We are constant from -4 to 0. Constant just means flat. Let's see. Relative max and min. Technically, this would be considered a relative min. And we don't have a relative maximum. This could be, but we're going to stick to relative max and mins are going to be tops of hills and bottoms of valleys. We're not going to worry with the weird ones like that. All right. So the next thing, even and odd functions. I forgot that was in here. All right. So a relative minimum and a relative maximum. Okay. This should have been on a different slide. I don't even know what that's about. Even and odd functions. Look at this. So ignore this. All right. So an even function is if you can plug in -x and you get the same thing back. So if there is a point at 2, 4, there should also be a point at -2, 4. For an odd function, if there is a point at -2, 4, there should be a point at +2, -4. So what we're saying here is for an even function, it's going to have what we call y-axis symmetry. I can fold the picture in half and everything lines up. If there's a point in quadrant 1, there's a point in quadrant 2 that lines up with it. For an odd function, it has what we call origin symmetry. I can rotate it around the origin 180 degrees and my points line up. So something in quadrant 1 has a friend in quadrant 3. Quadrant 2 has a friend in quadrant 4. All right, so if we look here, this is an example of an even function. This is an example of an odd function. All right, so you see how this point has a buddy and this point has a buddy. All of these points have a buddy over here. It has a y-axis symmetry. If I fold it on the y-axis, everybody lines up. So this point has a buddy down here. All of these points have a buddy down here. If I take it and put a pin in it here and rotate it 180 degrees, it's the exact same picture. It's called origin symmetry. All right, so we have to determine what we're looking at. So you have an option. You can put it in the calculator and look at the picture. You can also just stop and think, if I plug in a -x, what happens? So if I change this to -x squared plus 6, if I do a negative times a negative, it's the same thing as a positive. So I haven't really affected anything. This is exactly the same as this. That means that it's even. If I plug in a negative and I get the same thing back, it's even. All right, here, if I plug in a -x, a negative to the third power is a negative. So this term becomes negative. Negative times a negative is a positive. This term becomes positive. So do you see how both of these change signs? So since I got the exact opposite, then I have an odd function. All right, so this one, if I make it -x, a negative to an odd power is a negative, so I can just pull the negative out front. But I haven't done anything to change this one. So I changed one piece and not the other. So it's some has changed, some has not. That makes it a neither. Those are your 3 options. Even, odd, or neither. Even, everybody stays the same. Odd, everybody changes sign. Neither is some of each. Looking at a picture, even means y-axis symmetry. All of these points have points over here. Odd means origin symmetry. Everybody here has a point here. All right, so here's some for you to try. All right, so just looking at the picture, I vote that this one is a neither. I don't know what happened, why I can't write all of a sudden. I have no idea, it just kind of froze up. Okay, so I'm going to talk you through it. This one is neither because it doesn't have origin symmetry. This guy doesn't have a friend here and he doesn't have a friend here. So no y-axis symmetry, no origin symmetry. Number 4 is neither. All right, so looking at these three. If I change the sign of x, both of these are odd, so both of them are going to change. So this is an odd function. If I change the sign of x here, the even one will stay the same. The odd one will change. So this is a neither. Here, the even will stay the same. The even will stay the same. There's no variable here, so it's going to stay the same. So this is even. So odd, neither, even, neither. I don't know why it's being confused. I switched to my other mouse and it's working. Okay, so let's see how this goes. All right, so a piecewise function. They give you an example. It's like a word problem. So it's really just giving you a description and then the function. So we're saying that we're going to pay $20 if we have between 0 and 60 minutes of talking. And then we're going to pay $20 plus 40 cents for the minutes over 60. So we use this part of the function if we're between 0 and 60. We use this function if we talk more than 60 minutes to see what we're going to pay. All right, so the way this works, if I want to plug in a 30, I have to decide which one of these it fits. So 30 is between 0 and 60, so the answer is just 20. 100 is more than 60, so we have to do the math. So we're going to have to plug it in to this formula. So 100 minus 60 is 40 times 40 cents. There's a decimal right there that didn't work out very well. Is going to be 16, so you pay $36. All right, C, you have 40. 40 falls between 0 and 60, so it's just 20. And then for D, you have 80. 80 is more than 60, so you've got to do the math. So that's 20 times 40 cents is 8. So you have $28. All right, so here's another piecewise for you to try. This one doesn't have a word problem associated. It's just this function has 3 pieces. That's what piecewise means. It's multiple pieces to one function. So like that one that we did up here that look like this, that's a piecewise function. It has different pieces. So for this one, if I plug in a 3, does 3 fall in this category, or this category? It falls into the middle one. So we're going to plug it into that middle function. So we'll do 3 squared plus 3. So 9 plus 3 is 12. Negative 2 is less than negative 1. So we'll do negative 3 times negative 2 plus 7. So what is that? 6 plus 7 is 13. I was second guessing myself. I'm pretty sure I'm right. All right. Negative 1. It's kind of tricky because you think here, but it's actually here because that's where the equal to is. So we'll do negative 1 squared plus 3. So 1 plus 3 is 4. And then for 4, that goes in the bottom, so we just get 5. All right, that's all for that lesson. If you have questions about even and odd, then let me know, and I'll go back and actually work the ones on the You Try page out and see if that helps.